You'll find in polygon, you can say polygon on the left side. Usually polygon is number 4, you have square, 5 for pentagon, 6 for hexagon, like that. Depends on the number of sides. So when you select a polygon or you type for polygon, okay, now it will ask you the number of sides first. How many number of sides? So we need 6. It's a hexagon, so we type 6. Then it will ask you to specify the center. We'll specify the center anywhere. Then we have two options here. This is important here. I'll repeat it again. We have two options. When you select the center, it will ask you inscribe or circumscribe. There are two options. Inscribe, we say I, and circumscribe for C. We can see below there are two options. I for inscribe, circumscribe for C. So I'll show you both. What is the difference? I'll tell you. Now, if you see the hexagon, there are two dimensions for a hexagon actually. See this dimension from here to here, yani the vertical distance we call as width across flats, because it's a flat from here to here. It's one dimension. Another dimension is from here to here. This dimension is called width across corners. Width, because it's a corner here, we say corner. So I'll show you I and C. How you're going to see. We usually draw using circumscribe when you are using this dimension, and we draw with using inscribe when you're considering this dimension. Yani width, if you are taking width across corners, we use I, that is inscribe, and if you're using width across flats, we use C. I'll show you the both option. Okay. First, let us calculate the width first as per this formula. What is the formula? The first formula is using width, that is width, which is given 1.5 multiply the D is 20. Okay, thus we need to calculate. Then only you will be able to draw the hexagon. So I'll use a calculator here. So 1.5 multiply D is 20. So it will be how much? 30. So 30 is my width. Now, I would say I'll show you C and I, what is the difference. First, I will draw with C, okay, circumscribe. Now here comes the important point. It is asking me the radius. Now, whenever you specify the radius, remember, you must specify the radius half of the width. Now, what is our width? Width is our 30, because you got 1.5 multiply 20, you got 30. So when you specify the radius, it must be half of the width. Any half of 30, it must be 15. Otherwise, it will be doubled. I'll tell you why. See, I'll show you. I'll type here 15. Because my width is 30, I will specify half of it. So if you type, see. Now, if I go and the dimension, if I check the dimension from here to here, see this one, I got 30. If you don't specify half, then it would be double. And if I type the same as width, if you specify the radius at 30, it will be 60. So that is a mistake here. So whenever you draw the hexagon, remember, when you specify the radius, it must be half. I'll just show you the other example with using I, how you're going to use it. Like I want to draw another hexagon. Okay, same polygon. Number of sides 6. Okay, I'll specify here. Okay, now you see I'm not using C, I'm using I here. I just want to show you the difference between I and C. Inscribe or circumscribe. I. Now I'll use the same radius, that is 15. Okay. Now you see the both hexagon. When I draw a circle inside using radius 15, that is radius 15, same 15, same circle. I will draw it here, radius 15. You see the difference between these two circles? When you check the width from here to here, it will be 30. That is the difference between I and C. This is using C, circumscribe, and this is using I. So that is the difference between these two. Both are different, because this one is circumscribe, and this one is inscribe. That's why you see the circle inside, the hexagon, and here you see the circle outside. And if you see the dimension, we see the 30 is across the flat, the vertical distance, and this 30 is across the corners, that is the horizontal distance. So don't get confused. Okay, you must have, whenever you draw the hexagon, remember you must have this dimension, width across corners, that is 1.5d. We are not considering this one. Okay, and if you want to see the dimension, you see this one, you want to check this will be something different, and this will be something different. So you need 30, we need 30 exactly in this position, that is width 1.5d. Okay, so I'll just delete this one because I just wanted to show you the difference. So remember, when you draw the hexagon, you draw with C. But don't worry, even if you forget whether to use inscribe or circumscribe, you have option to check the dimension, go to the dimension and check whether you have drawn or correct. If your dimension is wrong, then you have only two options, either C or I. So you can check both and check the dimension, and you can move forward. So this is our uh, formula, that is 1.5d. I've written here. So I'll write also here the width what we have taken here. That is 1.5 multiply the d, which is 20. So we got 30. That is, I'll write 20. So this is our dimension here. This is width across corners. Okay. Now after drawing the hexagon, I told you, you must check the dimension of the hexagon. If it is right, then move it. If it is wrong, then correct it. Because if this hexagon is wrong, then entire projections will be wrong. Now I'm going to draw the the remaining bolt and nut. I'll just extend this center line because I need to uh, draw the bolt and nut here like this. We need to draw this bolt and nut. Remember, center lines, visible lines are very important because this is a bolt and nut is a cylindrical body, so you must specify the center. Now, I'm going to project the lines. Let me take color. So I'm going to project it from the end of the hexagon. You see the lines? You need to project the 4 lines like this. Even if you see the lab manual, it is clearly shown the projections. Okay. Now I'm going to draw the bolt somewhere here and the nut. So first I will take a line something like this. Okay, let me just take the color. So now I will draw the bolt thickness here. Okay, let me take the total length, then I will be easy. So as per the assumption, what we have assumed is the total length will be 80. So I'll offset 80 from here to here. So now this will be my total length of the bolt. Okay, and within this I will draw the bolt here and the nut here, somewhere here. Okay. Now first I will draw the bolt. So what is the formula for bolt thickness? This is 2 by 3d. So from here to here, you need to take the formula 2 by 3 multiply d. The d will be constant. We assumed 20, so d will be same. So what is the formula? 2 by 3. 2 divided by 3 multiply 20. So this is how much? 13.33. So I will offset 13.33 from here to here. Okay, this is the bolt thickness. Similarly, we'll take the nut thickness, but if you see the nut, this is slightly moved up. It is not, the nut is not exactly from the corner. This is the bolt end. The end of the bolt is there. Slightly you have some dimension here. So usually we take this dimension as 5 from the end, and then we fix the nut. This is the nut thickness, that is 7 by 8d. So the formula for the nut thickness is 7 by 8d. You see this? There is an end. This one. This is the total length. From here to here is the total length. This is 80 we assumed, and this would be 5. Okay, and after that we'll take this as 7 by 8, D. So what I'm going to use it? First, I will offset the 5 for the end of the bolt, and from this line, I'll take the nut thickness, that is 7 by 8 D. We have the formula 7 by 8 multiply D is 20, so this is 17.5. So I'll offset the 17.5 from this line. Okay. Now, so this is the nut thickness and this is the bolt thickness. Now, I'll just try to trim it in order to have a clear idea. Okay. I'll just remove the lines. So now, so you got a picture that this is the bolt thickness and this is nut thickness. Now the important thing here is, and then the next step is we are going to draw the arcs. Okay, we have the arcs. If you see the picture, we have arcs to draw for the bolt as for the nut. So I'm going to show you how you're going to draw the arcs, and after that we are going to take the capital D and small d. If you see the picture here, we have capital D. This is called D. That is D. That is 20, and we have two lines inside. That is small d. We discussed this in exercise 2.1, how you're going to show the capital D and the small d. So the D, this is the capital D from here to here, that is 20. And this is a small d, you will get it from the formula, that is small d is equal to 0.85 multiplied D. So I will draw the arcs first and then we are going to take the D. Now there is usually a common mistake done by the students. What they assume is, what they consider is, when you in the drawing, see these lines. See, this line is a projection from the hexagon. Actually, these lines, if you see, this is a projection from the hexagon only for the arcs. What the students do generally, they think that this is the capital D. They just project it or they forget it to delete the lines, and they think that this is D, but this is not D. You see the dimension from here to here. This is not capital D. So it must be D. Always when you take the capital D, take from the center. So I'll just remove it because it's just the lines for the arcs. Now I'm going to show you the arcs, how you're going to project the lines, draw the arcs. So we have a method here. If you zoom out, zoom in the picture, if you see, you can see this one. You can see slightly. I'll zoom in. In order to draw the arcs, we need to draw a line here. See, from the end of the circle, not from the end of the corner. See, end of the circle. You need to drop a straight line. Whenever it is touching the head of the bolt, we need to draw a line 30 degrees. See, it should minus 30, and it should go down. From there, we are going to drop another line, and within these two lines, we are going to draw the three arcs. I will show you that one. Now, as I told you, what we are going to do is, first we are going to drop a line from the end of the circle, from this end of the circle, not from this end, from wherever the circle is ending. So wherever it is touching the head, so from there, we are going to draw a line like this. That should be 30 degrees. Okay. So wherever it is touching, we are going to draw another line like this. So between these two lines, we are going to draw the three arcs like this. That is a method here. So I'll show you that one. So I'll start from the end of the circle. Okay, straight line. Then you should take 30 degrees. The angle should be correct. 30 degrees. Any 30 should be minus. It will be like this. So you can see here. I'll take 30 exactly. Yes, I got 30. Then I will mirror it. I need it on the other side as well. Now after that, I'm going to draw another line. The reason why I'm taking this line, because I can draw the three arcs between these two lines. So you must check the angle before you draw. Now how we are going to draw? We're going to draw using 3-point arc. Just take 3-point arc. So you take 1, 2, and 3. You got the middle arc. Now we have two arcs as well on the right and left. So what we do is we need 3 points. 1, 2. See, the second point is not available. What we need to do is simple. We just take a small line from here to here. So it will show you a midpoint. 3-point arc. 1, 2, and 3. Similarly, I'll take small line again from here to here. I'm doing this because I need a midpoint. It will show me a midpoint, so that will be my second point. 1, see, midpoint, 2, and 3. So once you got this one, what you just need to do it, you just need to remove this line because we already have taken the line. So this is again the angle. No need to delete the angle. Simply what we need to do is we just need to trim this corner like this, and then you just trim the line. See, your arcs are ready now. So you got the arcs. So when you check the angle, you see if you want to, when you put the dimension, see this line to this line. As per the drawing, it should be a 30 degrees angle. Are you following or not? Is it visible?
Yes, yes.
Okay. Now we need the same arcs for the nut. You need the same method, but the nut is upside. You know, it is. If you see the figure, when you see the exercise, the nut, the arcs for the nut will be upside in the opposite direction. The arcs are like this for the bolt because you are going to fix it like this from the down. So the arcs are opposite. So what we need to do, we need to do the same thing for the nut as well. But what I will do, I will, in order to save my time, I will not draw the arcs for the nut. I will just copy the same arcs because the width is same. Because this width from the hexagon, the width is same from top to bottom. So no need to draw it again. For saving your time, what I will do, I'll just copy this. Just simply copy with the angle. Okay. Now what I'm going to do is all I will mirror because there is opposite side. You can mirror it, but there is no center. So somewhere I will mirror it here. See, I got the arcs here somewhere. See, I just copied the same thing from the bolt and just mirror it somewhere here. So what I'll do is I simply move this from this midpoint. See, I'm just saving the time. I'll keep it here. See, simply. Then I'll just trim this. You can draw it again if you want, but just to save your time, you can simply use the same arcs from the board and you can copy this and rotate it because you can just mirror it and move it, or you can copy and rotate whatever you want. So I hope you understood that how I copied the same arcs for the nut, because you cannot mirror the same because this is 2 by 3D and this is 7 by 8D. Both dimensions are different from here to here. Let's bold this. That is given by 2 by 3 multiply 20. That is equivalent to 13.3. This is the dimension for that. And this writing for your understanding. And this dimension is nut. So this is nut thickness that is given by the formula 7 by 8 multiply 20. That will be 17.5. Now, now your bolt and nut is ready. Now we are going to take capital D and small d. You can take in the beginning, but it will create confusion. There will be many lines, and students, they confuse between many lines. They assume this is D. So this is not D actually. We'll take D from the center and small d from the center. Okay. So it's better to take capital D and small d at the end. Okay. Now we'll take capital D and small d. Usually from the center always. So from the center line, I'll take the D, big D and small d. As you know that we have a formula for small d. You already know that. That is minor diameter. That is small d. The formula is 0.85 multiply capital D. That is 20 here. Write the formula. Capital D. This is for the minor diameter. First, I'll take the capital D. That is major diameter. Offset 10 because the D is 20. So I'll offset 10 on both sides. So this is my capital D. The blue lines is my capital D. You can see the difference. See, this is just a line for the arcs, and this is our capital D. Similarly, I'll take the small d from the center. So you need to calculate small d from the formula. That is 0.85 multiply d. That is, use a calculator. 0.85 multiply 20 is a d. So we have 17. 17 means 17 is a small d. So how much I can offset from both sides? I can offset 8.5 from the center. So I have the small d. This is our small d. I'll use a other color so that you can identify easily, like this. Now the blue lines is a capital D and the red line is a small d. Now I will take the thread length. If you see the figure, we have thread length from here to here. So we are assuming some 36, or it doesn't matter, but just for the sake of drawing, I am taking 36. You can also assume 30 or whatever like, but choose the thread length close to the nut, not in the middle, just close to the nut somewhere here. So as I told you that we are going to take the thread length. This is the end of the bolt actually. Let's say this is the end of the bolt. Okay. Now I will take 36 as my thread length. Okay. From here, this is the end of the bolt, and this. So this is our thread length from here to here. Now I'm going just trying to trim this small d. Okay. And remember, always whenever you draw capital D and small d, this capital D and small d should not come inside the bolt or inside the nut. So if you see the nut, there is only lines for the arcs. I will just zoom in. See this clearly. See, there are only lines for the arc. The capital D and small d should not come inside the hole, inside the nut, inside the bolt. Only it should be outside. You see these two lines, capital D and small d, capital D and small d should be outside the nut. Only the nut should have the lines for the arcs. So here, if you see, I need to trim this. For example, this is the extra lines. See, the blue is capital D and the red is small d. So I would trim that such that this capital D and small d should not come inside the nut. So this is the nut. So I'll trim, you see, I'll trim the capital D, I'll trim the small d, capital D and small d. So that this capital D and small d should be outside the nut. Okay, take care of this. Okay, now the final thing is need to draw the angle, which we did in exercise 2.1 last week. You remember, one side we did 45 degrees, the other side we did thread run out. I have shown you the exercise I hope you remember that one. To go back to the exercise 2.1, you see this one. See, we did this one side 45 degrees and one side thread run out. This will be constant wherever you have the thread length. One side will be 45 degrees chamfer, the other side will be end of the thread, that is thread run out 30 degrees with the center line. The same thing is here because you have a thread here. Whenever you have a thread like this, there must be one angle will be 45 degrees, and then we have a thread run out here like this. So this is 30 degrees with the center line, and this is 45 degrees here. So I'm going to draw that. We'll take from the small d to capital D at an angle 45. You can see I will take 45 like this. Okay, same thing. I will mirror it on the other side. Okay, mirror it. So once you have the line there, so you just need to join like this. We did this one in exercise 2.1. It's not a new method. So after that, you just need to trim this. So you have the angle. Similarly, I will draw the thread run out, that is from small d here from the other side. Yeah, this one. This one, I'm talking about this one. Now this one I want to draw. From small d again, you have to take an angle. Take a line from small d. Okay. Now, as I told you, thread run out always, it should be 30 degrees with the center line. You have to measure from the center line. So I need this 30. So how much I have to take on this side? See, this is total 90. So if I take 60 here, then it will be 30 here. So I need 30. So you need to take 60 on this side. So I'll take 60, 60, because I need 30 with the center line. You have to calculate with the center line always. If you want to see, go to the angular with the center line, this line. See, this should be 30. And this is all ultimately this will be 60. That's the reason I have taken 60 so that I can get the 30 degrees with the center line. Always remember, thread run out is a line. You must draw a line which should be 30 degrees. It should be 30 degrees with the center line. So I'm going to take the same line on the other side, just mirror it, and then trim it. So your drawing is finished now. You already have done. Again, you see this. There is again the capital D is coming inside the bolt. So please trim it like this, and just simply delete this one. So your bolt and nut is ready with all dimensions. Also, you can put the angles. I put the angle for the thread run out, and also angle for the 45 degrees chamfer. Like this. So once you've done this one, the other side, which is the side view, it is actually very simple. It will take just 2 minutes to draw, because we are going to project from here. Okay, so this is important. And whenever we are going to represent in the assembly, because whenever we show it in an assembly in the coming classes, this is just a construction only for this exercise. We are drawing like this, but when we draw bolt and nut, we usually represent something like this in an assembly. The same construction, but you will have some parts like part A, part B. You're going to join this, and you have a through hole, and in that you're going to show a bolt and nut with the same formulas, with the same. We're starting with this hexagon 1.5D, same rule, and then projecting, but it should be exactly in this hole. Okay. Now coming to the side view, this is very simple. What I'm going to do is, for this exercise, if you see the side view, simply this hexagon is slightly rotated 90 degrees. You see this is side view, and that's why you see there are only 2 arcs on the right. There are not 3 arcs because it's just a side view, and there is no angle here. If you zoom in on the side view, see there is just a box. There is no angle. Just you have arcs here for the bolt and nut, and the remaining, the capital D, small d, the angles will be same. Only thing, the difference is the width. This will change. I'll show you what is the difference. If I take the hexagon, I will copy this one. I'll put it here. Okay. Now, what is the difference here? I just need to rotate this 90 degrees. Okay, go for rotate, center, click the center, and just type 90. See, I have rotated. If you see the dimension, this will be my 30 now because I have rotated. See, if you see, this is 30 from the width, but this is 30 because I have rotated. Now, what happened when you rotate, the width will change. Yani when you project the lines, see what I'm doing? I'm just projecting the lines like this. Sorry. Within this width, you're going to draw the bolt and nut. So I'm just trying to project the lines. I'm not drawing it again. See, I'm taking the same bolt thickness from the front view. And also I'm taking the nut thickness. Also, I will take the second line, that is after getting the angle, after taking the 30 degrees, you have a second line here. Also, I will project it so that I can draw the arcs. But the arcs would be only two arcs. So I'll take the same line. Okay. This is the center line. Now, what is the difference? Is just after that, I'll just trim all this. Don't need this one. Okay. So that is how. See, this is only the difference we have. So only thing, we are going to draw the arcs now. I'll just simply take the line. You can see. Show you how to draw the arcs. But here, use 3-point arc. But only thing, we don't have 3 arcs. We just have 2 arcs. 1, 2 in the middle, and 3 like this. 1, 2 somewhere here, like this. Only 2 arcs. Here, no need of angle here. No need to do 30 degrees because if you see, it is a side view. So there is no material cut here. There is nothing angle. Only in the front view you have this 30 degrees angle. Here you just keep it as a box. So only you have 2 arcs like that. I'll just simply draw like this. Okay. I'll remove this line. So it will be like this. Similarly, arcs for the nut. Upside down now. This is taking 3-point arc. 1, 2, 3. You can take the midpoint as well if you want. So I'll delete this line. That's it. That is the difference between this view and this side view. Now the rest is same. The capital D, small d is same. So I'll not draw this. I'll just simply copy the capital D, small d with the angles. See, I'm just simply copying in order to save my time. So I'll copy from this point, this point. That's it. So your drawing is finished. Understand? So it needs practice actually, because you have to see 2 to 3 times to understand. That's the reason I have given you the video. So please go through the video. There are 2 links. So that will help, inshallah, to complete the exercise. So for this exercise, you need to draw this 2 view, front view and side view with the dimensions. Okay, this is the construction of hexagonal bolt and nut, and you must remember the formula like width 1.5d, bolt thickness 2 by 3d, nut thickness 7 by 8D, minor diameter 0.85D. These are constant, okay? This will be constant. Only D will be given to you, and based on that, we are need to calculate and draw accordingly. I hope you understood this.
It's clear.
You have any questions?
No, thank you, teacher.
Okay. So for this exercise, you have 1 week time. I think from the before the next week till Monday, you can submit this exercise. Okay. And just to remind you that please name your file with ID name before you upload in the Blackboard. Please name your ID, okay, and name so that it will be easy for me.